So this one's building on the tangent ratio that we've already gone over. Before I go on, I want to show us some kind of a way to help remember these. I mean, it's SOHCAHTOA, SOHCAHTOA, right? SOHCAHTOA. That should be something that we remember from now, from now on. We can split it up in sections of 3. We have sine, cosine, tangent. O stands for opposite. H stands for hypotenuse. A stands for adjacent. Let's look at the bottom one. We have tangent. We know that tangent is the ratio of opposite over adjacent. So if we look at this, generalizing what we know about tangent, we can say, well, sine is going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. So we need to remember those 3. That's going to be something you're going to want to commit to memory. If you can remember that without SOHCAHTOA, that's okay. But a lot of the times, at least for the next couple tests that you take that you have to use trig, it would probably be a good idea that right at the beginning of the test, you write down SOHCAHTOA somewhere on the test. That way you're able to help yourself remember this. All right, let's look at our actual notes now. We have right here, sine of A is the opposite over hypotenuse, right? And we deal with that the same way we did the tangent ratio. And then we have cosine of A would be adjacent over hypotenuse. So let's look at example 21. We want sine of S. Well, from the perspective of S, this is the opposite, adjacent, and hypotenuse. So from the perspective of S, 21 is opposite, and 29 is the hypotenuse. I'll go ahead and write that as a decimal because I don't think that's going to simplify, and it would be 0.72. Now for sine of R, or we'll say cosine of S still, cosine of S. That way we stay from the perspective of S. Cosine is adjacent, so 20 over hypotenuse, 29. So 20 divided by 29 gives me 0.69. Now for sine of R and cosine of R, I'm going to erase my markings on the triangle. So I'm looking from the perspective of R now. Here's my hypotenuse, here's the opposite, and here's the adjacent. Sine of R is opposite over hypotenuse, 20 over 29. 20 divided by 29 is 0.69. And then cosine R would be 21 over 29, which is 0.72. We should see something interesting here. This and this are the same. This and this are the same. Okay? That's going to be true for all triangles. That's something to notice. The sine of one acute angle is the cosine of the other acute angle. And, oh, would you look at that? The sine of an acute angle is equal to the cosine of its complement. The cosine of acute angle is equal to the sine of its complement. That's what I was just trying to show you guys. That's cool. Let A and B be complementary angles, then the following statements are true. So the sine of A is equal to the cosine of 90 minus A equals cosine of B. And I'll let you guys read the rest of those. Example 22. Write sine of 71 in terms of cosine. So sine of 71 degrees is going to be equal to cosine of 90 minus 71 degrees, which is equal to cosine of, well, what would that be? What's 90 minus 71? Is that 21? 29? 90 minus 71? No, 19. And we should really have a degree symbol there. Next up, we have cosine of 56 degrees is going to be equal to sine of 90 minus 56 degrees, which is equal, 90 minus 56 is 34. So that's going to be sine of 34 degrees. All right, what this is saying here is that if we had a triangle, and I'm going to focus on this top one here. We have a triangle. We have 71 degrees here. Here's our right angle. This other angle here has to be 90 minus 71, which is 19 degrees, right? So this is doing kind of more of an algebra version of what we were doing up here with the yellow highlightings, looking at the other angles, right? That's what we're doing by 90 minus the other, right? The sum of all the angles in a triangle is 180, but this one's 90, so 180 minus 90 is 90, so these two have to add up to be 90. That's what we're doing here. Now let's look at the next page. Find the values of x and y using sine and cosine. So let's start off with we're looking from the 28-degree angle. We have opposite, adjacent, and hypotenuse. Well, starting off to find x, we know that x we could find using sine. So sine of 28 is opposite x over hypotenuse 15. So x equals 15 sine of 28. And I'm going to just leave that as that for just a moment, and I'll type that in my calculator after I find y. To find y, that's the adjacent. So adjacent and hypotenuse are the ones that we have for y. So I'm going to use cosine. So it's going to be cosine of 28 is adjacent y over hypotenuse 15. So y is 15 cosine 28. So typing this in the calculator, I'm going to go back to x. So 15 sine of 28, that gives me 7.04. And then for y, it's going to be 15 cosine of 28, and that gives me 13.24. So these are my answers. Next up, is this our last one? It is. We'll look at this one first. We're looking from the perspective of 36. This would be my opposite, adjacent, and hypotenuse. Looking first at A, I know that A is going to be dealing with sine because it's opposite, and I also have my hypotenuse. So sine, here, let me change colors. Sine of 36 is going to be equal to A over 25. So A equals 25 sine 36. And you don't really need the parentheses. Sometimes they're just nice to make it look better. I'm going to find my other variable before I type that in a calculator. To find B, I know I'm going to use cosine because it's adjacent. And I also have my hypotenuse, so I'm going to say cosine of 36 is B over 25. So B is 25 cosine 36. I'll go ahead and type these in my calculator now. 25 sine 36 is going to be 14.69. And 25 cosine 36 is 20.23. All right, there we are. Moving on to the next one. We'll start off with looking at our angle. Here's opposite, adjacent, hypotenuse. I think it's beneficial to write the letters, especially for problems like this where we only have one angle. So looking at it from the perspective of the 43, we have opposite and hypotenuse. We'll deal with sine first. So sine 43 is opposite y over hypotenuse 25. So y is 25 sine 43. Looking at the other variable, I can say cosine of 43 is x over 25. So x equals 25 cosine 43. Typing these in, I'm going to have 25 sine 43. That gives me 17.05. 25 cosine 43 gives me 18.28. All right. Lastly, this one's a little bit different because our hypotenuse is an unknown. So did it tell us how we have to solve these? It just said find the value of each variable. So let's look at our 20. This is opposite, hypotenuse, and adjacent. Starting off, let's ignore the hypotenuse. We're just going to look at S, and we have this other known. Which tangent rate, or well, there I've said it. Which trig ratio has opposite and adjacent in it? And you should be saying, well, that's tangent. So we know that tangent, and I need to do a cursive T there. Tangent, and the reason that I'm doing cursive T's is because they look a lot less like a plus sign, like an addition sign, right? It's good to use cursive T's, and a lot of the times I try to use cursive L's as well. That way they don't look like the number 1. So tangent of 20 is going to be S over 117. Right? I used opposite over adjacent. Solving for this, S is going to be equal to 117 tangent of 20. And I'll type that in just a moment. Now we need to look at, we've got our unknown, our hypotenuse, and then we have our adjacent. Well, which one compares our adjacent and hypotenuse sides? That would be the cosine. So now we can say cosine of 20 is adjacent 117 over hypotenuse r. Solving for r there, I'm going to have r equals 117 over cosine of 20. All right, let's type these in. I'm going to have 117 tangent of 20. That's going to give me 42.58. And then 117 divided by cosine of 20 gives me 109.94. There we are. This problem is probably the most like what you'll see in the future. Actually, I know it is most likely what you'll see in the future, where you've got some different unknowns and you have to make the decision, which trig ratio do I use, right? These two, it was very cut and dry. You knew it was sine, and then you're going to do cosine. These here, or this one, is going to be much more like the next section where you have to decide which one is missing, which trig ratio do I need to use. So there's that, and I think that's it, isn't it? Yep, that is it. So good luck on the homework. Let me know if you have any questions.